Hi, thanks for watching. The purpose of this video is to help you learn the difference between collinear and non-collinear points, to learn what it means for a point to be between two others, because it's not really as straightforward as it looks, to recognize that the sum of two sides of a triangle always bigger than the third side, and to recognize what we can assume and what we can't assume when we look at a geometric diagram. So I hope this helps, and thanks for watching. Oh, one more thing. Can you tell me the only word in the English language that has 3 pairs of double letters in a row? I'm not talking Mississippi, which has some double letters, but they're not consecutively. They have those I's in the middle. And can you tell me a word in the English language that's not a proper name that has 1 pair of double I's, like Hawaii? Think about it, and I'll tell you at the end of the video. Anyways, thanks for watching. Okay, Chapter 1.3 introduces 2 main concepts, collinearity and betweenness. Now, today in class I said the material is going to get more difficult. It really doesn't start yet, because this isn't very tough. Collinearity just means the points lie on the same line. So for instance, point A, point C, and point B would be collinear. However, if I added another point, like point K, it would not be collinear with A, C, and B. Now, there is some subtleness to this, because K and B would be collinear. I could construct a line through K and B. K and C would be collinear for the same reason, and K and A. But the 4 points K, A, C, and B cannot be contained by a single line. Therefore, they are non-collinear. So collinearity is really as obvious as it looks. Collinear points are points that lie on the same line, and non-collinear points are points that do not lie on the same line. So now let's take a look at this idea of betweenness. Betweenness is a little more complicated. Point C is between point A and point B. However, point K is not between point A and point B. In order for a point to be between two others, like C is, it has to be collinear with the 2 outside points. Alright, another way of looking at that more mathematically is this definition here. Betweenness of points. A point is between 2 other points if the distance between the 2 farthest points equals the sum of the distance from the inside point to the other 2. Huh? Okay, what that means is my distance from A to C is 4.55 centimeters. From C to B, this distance, that's 3.89. And the distance from A all the way to B is 8.44. Now, if I add the distance from A to C and the distance from C to B, I get a total of 8.44, the same as the distance from A to B. Therefore, we can conclude that C is between A and B. However, if I were to measure the distance from A to C and add that, the distance from A to K, and add that to the distance from B to K, we can tell that that sum would be much greater than the distance from A to B. Therefore, we can conclude that K is not between A and B. You could also just look at the picture. Only C is between A and B. A direct result of betweenness is something called the triangle inequality principle. And it states that in any triangle, the sum of 2 sides will always be greater than the length of the third side. So, the length of AB added to the length of AC will be greater than BC. Or I could add AC and BC together, and those would be longer than AB. You get the picture. Well, let's take a look at what happens when we manipulate point A. You can see that these two lengths are changing, but their sum would always be greater than 13.51. Now I've had the computer show us that calculation, and you'll notice that no matter what, this is always true. Except if I start moving A closer and closer to the opposite side, I can get pretty close until I get exactly at 13.51. But you can see I no longer have a triangle. I have a collapsed triangle. And this should make sense to us just with common sense. BC is the shortest distance because it's a straight line. It doesn't make sense that traveling from B to C by going through A, there's no way that could be shorter. So, in other words, the sum of any two sides of a triangle are always greater than the third side. This brings us to our final point in chapter 1.3, interpreting a geometric diagram. When you're looking at a diagram, what can you assume is true and what can you not assume? So let's start with what you can't assume. Looking at this triangle ABC, you can't assume a right angle. So angle ABC looks like it might be a right angle, but we can't be sure. So we can't assume it, not unless we're told. You can't assume congruent segments. So segment AD looks like it might be congruent to DC, but we can't be sure. You can't assume congruent angles. So I don't know if angle 1 is congruent to angle 2. Nor can you assume the relative size of angles or segments. So I can't be sure, frankly, that AB is shorter than BC. Nor can I be sure that angle 2 is less than the measure of angle 1. Okay, then what can we assume? Well, you can assume straight lines and angles. So AC is a straight line. I can be sure of that. I can be sure that ADC are collinear and that D is between A and C. Finally, I can assume the relative position of points, which is to say that if I were to look at this, I know that B is not on AC, that it is not between AC. Okay, I put together a tutorial on a problem that comes up involving the triangle inequality principle, and I hope you find that useful. So watch for the Edge of Creations video on iTunes U. Finally, the trivia question. This is your last chance to pause it. What is the only word in the English language with 3 double letters in a row? It's not betweenness. Betweenness has 2 double letters in a row, and almost 3, but that E sneaks in there. And what is a word that has double I in it? Okay, you ready? The answer to the trivia question is bookkeeper and skiing. Okay, thanks for watching.